people might not trust new technology right away, and we don't expect people to. People have to give it a try, learn things, and understand.
Welcome to Day 2 DevOps, where the DevOps is in the details. I'm Kyler Middleton, and I'm joined by my illustrious co-host, Ned Bellavance.
Hey, Kyler. Today we're discussing how to scale your Kubernetes cluster at astronomical scale with Goutam Tadi, a staff software engineer at Astronomer. With no further ado, let's get to it. Goutam, I want to start with I know how I got started in Kubernetes. I didn't have a choice because I was in consulting. How did you get your start in Kubernetes?
Yeah, I started off right in 2018, if I'm not wrong with respect to years. That was when I was working for Pivotal Software.
Okay.
Then Pivotal Software is a big company, though it is a startup. There are a lot of different things going on. One of them is Greenplum Database Organization. I was part of the Greenplum Database Organization then, and Greenplum was not cloud-based offering at that point. It was only a tarball-based installation on
Hmm.
bare virtual machines. And our organization decided to take Greenplum into cloud and make it more available so that there's more business. Eventually, we wanted to know what platform we wanted to adopt. So if you remember, there is a Bosch that came out of Pivotal, which is like an orchestrator of virtual machines, technically. But it was like Kubernetes is also just getting started at that point,
Hmm.
which is orchestrating in containers. So there was a lot of discussions, but eventually Kubernetes looked promising in terms of people adopting Kubernetes, contributing to Kubernetes, and the growing open source. So Pivotal immediately made this decision to get started off with Greenplum to be deployed in Kubernetes. That's not only one thing. There's more considerations like, okay, who could be using Greenplum on Kubernetes? Because Greenplum is a massively parallel Postgres database, and we want that to be deployed in containerized, which was then a perception that to be only considered for stateless services. But deploying a database, which is a stateful service, so we have to make a promise that how this is a right idea to deploy Greenplum database in Kubernetes. So we don't know a lot of answers. So then we formed a 2-member team to start off working on Greenplum on Kubernetes, and me being one of them. That's how I started getting in Kubernetes area and started to learn things about containerization, what are the Linux internals, C groups V1 and C groups V2. So that's how my journey started to get into Kubernetes side of things. And eventually, in 2 years later, we released a fully working auto-hailable Greenplum on Kubernetes product. Some folks might say that it is not really a great idea to deploy a production workloads. Maybe. But if you want to a development environments and if you want ephemeral environments and if you want to start something slow and steady, this is a great product for you. So that's our proposition at that point. And during that time, we were able to design and deploy a lot of different ideas. And out of that, we have come up with 3 patents during that time. And one of the patents have at least 30 citations. So we know how useful that was with deploying Greenplum in Kubernetes.
I want to ask about those 3 patterns, but first I just want to hear, so you started learning all this stuff, you started building even a database on top of Kubernetes, which scares me. I would be so scared to start doing that because, pods are ephemeral and they lose their data when they go away. When did it click for you that Kubernetes was going to be big? And maybe for databases specifically, when did you see that this tool that is based on a platform to run ephemeral workloads is going to be a great place to put my database? When did that click?
We started this project not with a confirmation, but the idea of exploration.
Mm.
Let's explore this area
Mm-hmm.
and see how it goes and see what it could bring to Greenplum. If that works, yes, it could work for some areas, but we are not expecting that to work for everything or for all kinds of workloads. That's how we started off with an idea to deploy Greenplum in cloud environments. And as the time when we started, there were no Kubernetes operators. It was all TPRs, third-party resources thing, which is equivalent kind of Kubernetes operators, but we did not adopt it immediately. We started off with a simple Python script to bring individual pods and attach volumes. That's how we started off. That was our MVP in Kubernetes. we tried to work on that. And so if you look at Greenplum, it's a segment database, and there's master and workers, and there's a standby component. So there's a lot of manual stuff that people have to do if they have to do failovers.
Mm.
And we wanted to automate those kind of things to auto load balance back to standby if at all something happens to master. And there's a lot of configurations that you have to require whenever you want to do like a SIG hub on the database whenever there's a configuration changes. So we wanted to do or automate a lot of these kinds of manual administration stuff. That's the major idea where we want to automate and get started. Any orchestrator platform would have its own disadvantages and advantages. And the only disadvantage that we have seen is there is a conception around that Kubernetes is good for stateless.
Hmm.
I wanted to challenge that. Like, why is only that? Why can't we adopt the stateful benefits that Kubernetes can give you where it can auto load balance things and where it can attach volumes to any compute that you bring up? Bring up a pod, attach the compute. After all, Greenplum is a persistent database. If you can provide a great availability on the volume, and if you have snapshot backups every now and then, that's how you try to adopt new technology and get the benefits out of it by adopting them. And you make changes. Of course, you have to make changes whenever there's downside of it. Like just like stateless, how do you do with stateless? You choose to store your data in some kind of S3 storage. That's how you make your stateless better in a way to adopt Kubernetes, because Kubernetes gives you a lot of other benefits for you. So similarly, if we could solve the problem of the more high available data in terms of volumes and more delete protection of the volumes, then that's how you can gain the benefits. People might not trust new technology right away, and we don't expect people to. People have to give it a try, learn things, and understand, question, challenge, and what are the workloads they could use. Yeah, I don't expect people to use in production. They could use in dev, staging, and run a lot of queries. Like for any data engineer or data analytics person, they wanted to write their queries first, test it out. Is the evaluation models are right? So those are the audience that we targeted, and we challenged ourselves to understand and learn and adopt the new technology benefits of Kubernetes back then.
I find it so interesting that many of the promises that Kubernetes makes remind me of the same promises the cloud made. When we first started encountering AWS and Azure was, you can deploy these ephemeral or rapid iteration workloads. Will provide the high availability on the back end for the infrastructure you're building on, and you just have to like deploy your apps. And at first, a lot of people did build stateless web apps up in the cloud, and then slowly we added on these additional features and functionality to give you a full range of options when it came to persistent storage and networking types. As you've seen Kubernetes evolve, your role has evolved as well. So I don't,
Yes.
you're no longer working with Greenplum. What are you working on now, and how does Kubernetes involved with that?
Yeah, definitely. Right now, I'm working at Astronomer as a staff software engineer. I started off as a senior software engineer there, and my role has been changed a lot since I joined. I started off in a part, sorry, team, part infrastructure work. It's grown into full-time managing customer infrastructure, where we manage hundreds of Kubernetes clusters and multiple thousands of nodes on all of these clusters across three clouds: GCP, AWS, and Azure. So that's the offering we provide, and we are a small knit team, but very effective team, I would say. And we manage all of these health of the infrastructure, upgrades, and making sure there are no CVEs and get up-to-date patches, and deploy our own services to monitor these clusters for customers. And there's any issues or questions that customers might have, we jump in and try to provide answers as quickly as possible. But overall, we are the team that's managing the whole of customer infrastructure, and I'm part of it full time right now. And yeah, that's what I'm right now.
You're the experts. You're the Kubernetes experts for the Kubernetes teams. That's pretty cool. And that would have helped me so much when I was getting started. You mentioned GCP, Azure, AWS, the big three of the hyperscalers.
Mhm.
Do you have specific clients that are deploying Kubernetes across clouds, sort of meandering workloads in between cloud providers? Because that's what I read is, Kubernetes is a standard. You can deploy it across your clouds. I've never seen anyone do it and at least do it successfully. I would love to hear some war stories.
So, yeah, I don't think there are customers that are on multiple clouds. Customers have a reason for that. Customers might have got some discounts or benefits from a specific cloud,
Hmm.
and their data might be in a specific cloud and in a specific region. What we wanted to provide is options. We are not stopping customers to create their loads in multiple cloud providers. It is customers who choose to deploy into a specific cloud in a specific region. And the reasons could be multiple. I just showcased one example because of the data locality and the data region where they want, because they want the orchestrator to be close to their data. That's one of the reasons why people could choose one particular region or particular cloud provider. But otherwise, there is nothing stopping today for customers to choose what are the cloud provider, what are the region they want to deploy Airflow in any of these three clouds.
Interesting. So we go on without Kubernetes living across clouds. So, folks at home, if you manage your workloads across clouds, please let us know because I still have not seen anyone ever do this, and I would love to.
We manage multiple customers. Customers are in specific clouds, but we manage all three types of customers who wants to be on all three clouds.
That's fascinating.
Another thing that is very different, you're talking about managing these Kubernetes clusters across 3 different providers.
Mhm.
And the thing about these different providers is, yes, they're all using Kubernetes at some level, but they all have their unique spin on it. And I know that can cause no end of consternation when you're trying to manage all these different clusters. One pain point I think you brought up in our planning call was that of identity,
Mhm.
like managing identity across the different clusters. Because all 3 cloud providers have their own separate identity provider, and how do you deal with that when it comes to the Kubernetes clusters?
Yeah, totally. Just like any platform that can orchestrate different services, we have similar kind of architecture where we have a control plane and data plane as two entities. Our control plane services are responsible to do all kinds of CRUD operations on these data planes, like bringing up infrastructure, deploying services, monitoring health, make updates. All of these are handled through the control plane communication to the data plane. And that specific thing that we wanted to bring up is this identity stuff. A little bit of history here is, though we are dealing with multiple clouds, when we started off way much early, there was not a great adoption of workload identity as a thing.
Mm,
Workload identity is basically using OpenID Connect to ensure that a specific workload is authorized to do something in other cloud. The defaults that clouds would provide you with is, for example, in GCP, when you create a service account, and when you create a service account, you grant a role, and you have to assume that service account and perform the operations. Simple. I'm a cluster admin role, so I don't have direct access to that service account. So how do I do that? I create a service account key. Okay, now I downloaded the key. That's the first security risk.
mm,
You download the key, put it on your local or somewhere you assume as a secure storage. Let's call it vault. Okay. And at the end of the day, you have to put it as a secret or mount it as a secret or things. I'm talking even before there exists like a vault injections, all kinds of stuff. This still you're dealing with static credentials here. That's still a risk. And once you have that risk enabled in your workloads, that risk continues. And once that credential is leaked through some other outside channels, it's either because of the phishing attacks or reverse engineering attacks or any kind of email phishing attacks where people ask to share things and because they mask as a CEO or someone at the high level, and that's doomed. So this is the exact problem where I think a lot of workloads are using across. It's not only for one cloud accessing other clouds, even for within the same cloud to access the cloud provider services. For example, I have a pod and I wanted to use S3 bucket from a different region or from a different account.
mhm.
So how to do it? You create a role, create a secret access key and credentials. You copy them over. There you go. Another set of static credentials. And how long you keep adding these credentials, those get piled up. especially when you're in multi-cloud architecture and you wanted to assume high privileged permissions to create, update, or manage these high paying customers' accounts. Every step has to be thoroughly revised. So here comes to our benefit the workload identity. It has been greatly adopted across all the three clouds that we're working, and you can establish workload identity from one cloud to other, and you can selectively grant different types of roles in terms of like you create a role in the respective cloud and tell this service account to assume this role. So how workload identity works is a Kubernetes cluster, by default, all of these managed Kubernetes clusters provide you with an OIDC issuer URLs. So you take this OIDC issuer URL from the host Kubernetes cluster where you want use the access, take this URL, go to the cloud provider, whatever you want to go and make changes to, go there, you create a workload identity there. Hey, this is my issuer URL. Please accept things that's coming from this Kubernetes cluster. That's not the end. That's only saying that this is my trusted Kubernetes issuer URL, but we did not grant any kind of permissions yet.
Right.
Then you go and tweak the granular permissions that you wanted to give by service account. By default, all Kubernetes services or pods or deployments, they have to be using some kind of service account already. So here comes a designing phase of problems like don't try to use same service account for a lot of different services. Try to have isolated service accounts because you can mount different service accounts for a lot of services, but try to mitigate and do the appropriate usage of that service account to a defined service and grant these permissions to that service account in that cloud provider with appropriate roles. That way, what you're establishing is you're creating a trust relationship with that third cloud provider and granting specific permissions or granular permissions. So what are the benefits that we're going to get out of this is this managed Kubernetes cluster is responsible to rotate the tokens on a given pod or deployment. That will keep rotating the secrets, which comes out of the box for you. And you don't have to do any kind of authentication mechanism. There are SDKs already which can take this secret and make the authentication request to the corresponding cloud provider, and that will grant you back the permissions. That way, there are a lot of cloud provider specific SDKs that can facilitate this kind of authentication for you out of the box. So the only thing you have to do is discard your static credentials, establish this one-time setup of OIDC between clouds, and boom, you can go ahead and start working on these things. You don't have to worry about any more leakages or things.
Right. And correct me if I'm wrong, but like when one of the pods wants to use its identity,
Mm-hmm.
the claim that gets sent over includes more than just that identity. It
Mm-hmm.
includes stuff like the name of the pod, the namespace that it's working in, the cluster it's coming from, and any other custom information you want to include. So you can make a role determination based off that information too.
With the service account based permissions, so when a Kubernetes provides you with a token, it's a JWT like token,
Okay.
and it has all the information about the service account, but not exactly the pod information
Oh, okay.
because we are granting permissions by service account in this case because we don't want to give it by pod or something. The reason is pods are ephemeral
Hmm.
and deployments can scale up pods. So that's one thing. The thing we want to be have is a long running consistent expectation of resources, which is like namespace, service account, technically.
Hmm.
And why service account is a beneficial in this scenario is in any case, if you want to revoke actions or permissions to a specific deployment using a service account, you can go to the second cloud provider where you granted permissions, just kick it out of there, revoking permissions for that service account. Then boom, whoever is using the service account in these pods will have the access revoked and you are reducing the blast radius there by using service account. So you have the flexibility of using a single long running entity, which is a service account, and it is a predictable and static. At the same time, you are by granting a granular permissions and isolated service accounts for different services, you are able to get that flexibility of revoking them if they don't want to access that particular role anymore.
Right. And every pod is getting its own unique token from this process.
Yes, yes.
Right. So you don't have one static credential that's being shared by all these pods. Everyone's getting their own individual token that's probably short lived
Yeah.
to a certain regard. And then it has to re authenticate when that token expires.
Yes, yes, that gets automatic. Like whenever you send a request, you use that token, and their SDKs, you don't have to even define anything. They just absorb that information and do that for you.
That's exactly how I thought it worked. I thought the service account authenticated, like in AWS EKS land, it's Ursa and gets a token and it just hands it out to the pods that ask for it. So it's great to know that there's more validation and more sort of, fingerprinting of the pods. Interesting.
Yeah, this is a very exciting way to get rid of all the pains of managing credentials, using external secrets operator and injecting credentials. That's a lot of pain and maintenance.
Totally. During our preview call, you mentioned that in Kubernetes, everything is DNS.
Yes.
I know much love to hate on DNS in the infrastructure world. Tell us more about that. What role does DNS play within Kubernetes?
Sure. This is a very interesting topic for myself. Like whenever I want to talk about DNS and optimizations, I get really, really excited about this thing because I try to create an analogy with humans. Like if I want to call some person, if you're meeting them for the first time, you talk to them using their last name. And once you get more and more closer, or you know the person, and you can call them by first name. That's how I think in Kubernetes. Like when it's come to pods and you want to talk to a person like another pod or another service, it's always a naming convention. Like if I don't have to remember the person's phone number if I don't want to call them, I just search for the name. Hey, call this particular person and talk to them. That's how I try to bring up this analogy with humans, and same thing with the services in Kubernetes.
Mhm.
And here's the interesting thing. So last name and first name, and how do that gets resolved? Because computers, when they talk to different things, they have to locate them by IP address. That's how they understand different services,
Mhm.
unlike humans. But our previous inventors created this DNS to just help humans. Hey, I know IP address is too much for humans. Let's give some naming conventions so that you know exactly to whom you're talking to.
Mm-hmm.
Okay, thanks to all those scientists. But today, at this huge scale of things that's happening around, especially in Kubernetes, there are some unknown bottlenecks that are causing on a day-to-day basis. On a day one, when you spawn a service or multiple services that could talk to each other or even talk to outside world, you start writing in terms of DNS because IP addresses are ephemeral in Kubernetes world and you don't know what IP address belongs to whom.
Mhm.
And that's a benefit of having Kubernetes because you only deal with names. You don't want to deal with these kind of inexplicable IP addresses or things. How does this DNS flow is very interesting. Like in Kubernetes pod, you write your code, hey, service A, go and talk to service B. That's at the application level that people write code. But how does that get resolved is interesting. In every Kubernetes cluster, there is a core DNS pod or core DNS service that is responsible for resolving these DNS addresses to a specific IP address. And now computers can understand, hey, yeah, I know this IP address. It's not in my virtual machine. I have to send it over the backbone network, see if that is in my LAN, and through the IP table routings, it goes to that particular service B, and boom, that's how it works. But I want to specifically focus here the timing between you sent a DNS resolver, you talk to the DNS resolver to resolve the DNS, and the time before getting the IP address, because this gets interesting here. So when you have, let's say, service A and service B, people tend to write just the service name, and it's not a fully qualified domain technically. And in Kubernetes, it is not really expected to write fully qualified domain names like service b.service.cluster.local. That's too much. But what happens here is when you do that, like a service B, the DNS resolving happens in this way. There's name searches in your etcresolve.conf, and it goes through all of the name searches. If, let's say, there are name searches like default.service.cluster.local, and there is service.cluster.local, there is cluster.local, and you can add more name searches too. So by default, this has 0 dots, which means there is no service B dot something. I'm talking about n dots here. N dots is something like number of dots in the DNS address.
Okay.
So if I say service B, the n dots is 0, which means by default, Kubernetes expects n dots equal to 5, which means if anything less than 5 dots in the DNS address go through the name searches, which means it goes through serviceb.cluster.local unless until it gets resolved. And only after all these queries failed, it gives you an error, unable to resolve IP address for this DNS. So what's happening here is you are continuously making all of these calls to core DNS pod.
Mm-hmm.
So core DNS is responsible, and core DNS is not a daemon set, so it is not resident of each node. So you still have to go over the network and get it resolved, get back there. So we are unnecessarily making a lot of DNS calls, especially with external addresses. Let's say www.day2devopspodcast.com. And there are only 2 dots in that, which means Kubernetes first tries to resolve that address with day2devopspodcast.com.service.cluster.local. Fail. Do that cluster.local. Fail. Do something else. Fail. Only then it sends to external provider, hey, could you find it? Oh yeah, it's with you. Get back.
Wow.
If you are doing these more and more calls from within the pod every time, it's doing the same thing unless until there is a local caching present. But even though, considering there's no caching of your DNS addresses, it has to do all of these failure calls and then go to external. So just think at the scale of thousands of requests that you're making per hour or per minute, just making not so good use of the calls to the DNS. So that's where a lot of DNS optimization come inactive and help you in reducing all of these unnecessary calls. And there's a lot of things that we can make this problem smaller. One of them is when you create a pod, try to choose a optimum n dots value. Don't try to make it 0 or things like either use 1 or 2. That's one thing. So that if you have anything like less than 2 dots, then it goes to the name searches. Otherwise, it goes directly to the external provider. And one more thing that I want to bring is core DNS within the cluster is expected to resolve all the IP addresses for cluster.local. Anything that is not cluster.local will be fall back to cloud provider's DNS provider to resolve it as an external address. So to help this, always use fully qualified domain names, especially for external DNS addresses, which means use a trailing dot at the end, which will help you directly going to external DNS provider to do that for you.
Oh, that's tricky. I wouldn't have thought of that. I think most people don't realize that all DNS addresses should technically end with a final dot.
Yeah,
We just don't write them like that because it feels strange.
right.
I've been on some DNS providers. I'm trying to remember one. It wasn't GoDaddy, it was like another one. But when you put in some of the DNS information, it expected that trailing dot and you would get a syntax error if you didn't include it. And
Yes.
that's like the only time I've actually seen that used.
Yeah, that's exactly the reason why people don't adopt this because it's not widely used or adopted.
Hmm.
This is especially for the external DNS addresses resolution
Right.
because we don't want to go through all these name searches for the internal, which we know that it wouldn't work. And on top of that, trailing dot, Kubernetes pods have this DNS config options that you can configure where you can configure n dots. And you can also define your own name searches. What are the name searches you wanted to go through specifically to that pod?
Mm.
And until recently, I think with 134, I believe, they're going to provide a support to use dot as one of the name servers so that by default, all the name searches will default external DNS provider and then fall back to local core DNS later. So that's one thing that's coming up. Like if a particular pod or service is doing a lot of external calls and they want to use fully qualified domain names and people tend to forget to use trailing dot, so you can use a customized dot in the DNS options that's coming up in next versions of Kubernetes, which is unsupported until recently. And there are more things that we can optimize these DNS issues. Like one thing is n dots, and another thing is using node local DNS cache. Some of the cloud providers provide it as a plugin, some of them don't. So use it according to your things. You can still deploy your own node local DNS cache even though there is a provided plugin. So it's very easy to configure.
Mm.
This node local DNS cache is nothing but a daemon set version of core DNS. It's basically core DNS running in a cached mode in each of the nodes where you can cache all the successful DNS resolutions for 30 seconds or more, and all the failed DNS addresses also for 5 seconds or more by default. So that way, you don't have to resolve DNS address every time you have to talk to an external one or external service. That way, you're caching it, which means you know the IP address already, and you're reducing the network calls by a 10x or 5x easily
Wow.
by just caching it locally. And it takes very, very few resources. It's just caching after all. That's one thing. That's another benefit that we could reap if you expect that you're doing a lot of DNS calls. And number three, this is specifically for node local cache configuration. If you know that you have critical services that needs to be resolved effectively, then you can configure node local DNS cache to use TCP to resolve the DNS address, because usually you use UDP for resolving DNS addresses.
Mhm.
But to ensure that you always get some kind of response when you're resolving an address, you can use TCP mode on this node local cache. That way, you know exactly that a particular thing is being resolved or not, and you can take actions based on that. Because with UDP, you don't know whether something is reached at the end or not, right? So
Right.
this is something that you can go one extra mile if you want hosting critical services. And besides these, you can configure your core DNS where you can totally reject IPv6 address resolutions. Because if you are bringing up your Kubernetes cluster using IPv4 as header ranges, you don't have to resolve IPv6 for cluster.local, right? Why is this even a thing? Why is IPv6 even a thing in DNS resolutions, right? There are certain libraries, like you don't get to write a library from scratch to make a request call, like for example, Python HTTPS library, like HTTP library or request library, sorry. That makes calls, if you don't configure that library usage, by default, it makes both IPv4 and IPv6 calls to resolve DNS. And it is a waste of another set of calls to core DNS to resolve both IPv4 and IPv6, because you obviously know there's only IPv4 address and there's no IPv6 addresses assigned to the pods within the cluster. So you can totally say, hey, core DNS, if you get IPv6 addresses, just say no error, which means you're not discarding that, but you say no error. So node local cache will cache it and reduce those IPv6 calls going further. And this is only a cure, but prevention is configure your libraries to make sure that they're not doing IPv6 calls for internal address resolutions. So choose wisely. So these are the different things that helped us in bringing a multiple number of complaints to zero complaints, at least for an year now. Like we are able to get more scale on each node of the cluster because there are certain limitations obviously for every node. For example, in EKS, there is 1,000 packets per second limitation on a network interface card. So if you're doing a lot of calls from within the same node, because there's a lot of pods and things running, they could be doing a lot of network calls on the network card. And these additional redundant requests would hamper the ability of the pods. So you're giving more room to other actual real work by reducing these kinds of DNS unnecessary resolution calls.
And right there at the end, all of that was fascinating, by the way. And I need to go check our configurations to make sure they're right. But also, you mentioned right there at the end that there was 1,000 packets per second limitation within EKS. I've never heard that before. And networking for NICs, it's always like bandwidth per second. Is it a particular VM size or pod scale, or what is 1,000 packets per second?
Irrespective.
Interesting. Where did you find that, and how do you control it?
I think you can go to the AWS documentation. You can see 1,000 packets per second limitation. You can find it. It's very, very hard number to reach per node, because by the time you reach that, like your pods would be occupying a lot of CPU and memory, and not all the pods might not necessarily doing a lot of network stuff. And if you have, especially if you have retry mechanisms within your pods and services, so they eventually will succeed. But why do you have to do a retry when, in the first place, if you could optimize your DNS in a way that it doesn't have to make redundant calls? So that's the core idea. But there's limitations, obviously, for in different ways. Like you cannot go beyond these many number of nodes within the Kubernetes cluster as recommendations, because some benchmark issues might hit, like for managing things. So This is one of the well-known limitations on networking side per node.
That's fascinating. And I love talking about DNS because it's just turtles all the way down, like it's just so complicated. And Kubernetes itself is like, it's kind of a cloud. So putting Kubernetes in a cloud is so funny to me because it's a cloud in a cloud. And like, surely it's so complicated.
Yeah.
I felt like I really understood it pretty well. This is like maybe 6 months ago. And then someone told me, how do I do a certificate, like an HTTPS certificate in Kubernetes, and make sure that it works for external traffic and internal? And I was like, oh, and I started to answer. And then I thought, oh, I don't have any idea how DNS works in Kubernetes. I have no idea how to answer that question. So I want to pose that to you just privately because I have no idea what the answer is. How do you manage certificates in Kubernetes when DNS is different for internal resolves versus external resolves?
Simple answer, cert manager. Cert manager is the one thing that you can utilize, and technically you can use Let's Encrypt service for the cert manager. And cert manager is a service that you can run in your Kubernetes cluster wherever you want. And you can get certificates from Let's Encrypt for all of your publicly facing addresses. And the process is a little bit not, I wouldn't say complicated, but there are two ways how Let's Encrypt would uh, make sure that you have all the rights to get the certificate for a particular DNS address.
Right.
And Cert Manager provides these two ways. Either they can verify on your DNS managed zone directly by using credentials and logging into your cloud provider wherever you're hosting the zone and adding a text record, whatever it can do. That way, it does that. And number two is Cert Manager can also bring up a brief sidecar container by itself where Let's Encrypt or Acme through an Acme challenge. It sends an Acme challenge through that sidecar and it returns a response to that challenge, making sure that you own this DNS address or that particular address or the particular domain. That way, also you can resolve the challenges, and that's how Let's Encrypt will share with you the certificates. So this is all automated process. Cert Manager takes care of the life cycle of the certificate, and you can configure it for how long a certificate should be valid. And all the challenging part and all the response part is taken care of by Cert Manager with the Let's Encrypt, and Let's Encrypt gives you certificates. It's automated, simple.
Interesting. So it fetches a certificate for the what cluster.local domain for your host?
No, I'm talking specifically with regards to external ones, like you had .com, day2devopspodcast.com.
Hmm.
That's the domain that you own and you want to obtain certificates for that. Like you can say net.devopspodcast.com or kyler.day2devopspodcast.com. So you wanted to create any of these different addresses or different websites for these two things. Cert Manager can do that for you. And with regards to internal ones, if that is okay, you can always go with self-signed certificates. And that is easy to generate self-signed certificates and do the creations. That's one thing you can do. Or you can use MTLS. I haven't configured MTLS in a long time, but Istio can do that for you also to have that extra level of security communication between services.
Right. I remember that being one of the benefits of implementing a service mesh like Istio was the fact that it would handle the MTLS
Yeah.
pods for you. You didn't have to worry about that. And it would just set up the MTLS tunnels automatically and verify pod identity and all that stuff.
Yeah. And also with more and more latest of these kinds of stuff, you don't have to do the all kinds of DNS address resolutions at this point. Like Core DNS might not be useful at this point because Istio being its own control plane and data plane like of architecture within the same cluster, it knows exactly the IP addresses and it's all communicated through their control plane in all of the data planes. So that's a different discussion in DNS optimizations totally.
That is fascinating. And I want to keep going, but Ned is poking me on the side and saying, we have to close up. We're going to go too long. So, Goutam, this has been so wonderful. If people want to hear more from you, and I know in our preview call, we discussed like 6 more topics that we didn't even get a chance to get to, how can they find you and learn more about Kubernetes from you?
I'm available on LinkedIn. You can find my LinkedIn URL, Goutam Tadi, and you have my email. You can find it. And also, I have my Medium blog posts, goutamtadi.medium.com. I try to put all of my learnings there whenever I find some chance. Yeah, these are the three avenues where you can find me. If you want to reach out to me, I will share my email too. It's gtaddy@ieee.org. You can reach out to me over there as well. And yeah, I'm open to discussing a lot of things more and more.
That's wonderful. Thank you so much for coming on and sharing your knowledge. It's wonderful. We appreciate it.
Thanks for having me.
Thanks to Goutam for appearing on Day 2 DevOps, and virtual high fives to you, dear listener at home, for tuning in. If you have suggestions for future shows, we would love to hear them. Really, we would. Hit either of us up on LinkedIn or send some feedback via packetpushers.net/follow-up. You can find me, Kyler Middleton, blogging over on letsdodevops.com, and my stupendous co-host Ned Bellavance at nedinthecloud.com. And we're both terminally active on LinkedIn. Stop by and say hello.
If you like engineering-oriented shows like this one, visit packetpushers.net/subscribe. All of our podcasts, newsletters, and websites are there. It's all nerdy content designed for your professional career development. And by the way, if you're attending KubeCon in Atlanta, give me a holler. I'll be hanging around, attending sessions, and recording some interviews. Maybe you could be one of those interviews. Ping me on LinkedIn if that sounds interesting.
Until next time, just remember that doing DevOps is awesome, and so are you.